In Chapter 9, Section 3, we're taking another look at parabolas and still addressing state standard number 16. And we need to talk about the geometry and graph of a conic sections. So we've got to include asymptotes, foci, eccentricity, etc. So let's take a reminder of geometry that a parabola is a set of all points in a plane equidistant from a fixed line. So here's our fixed line called the directrix. And from a fixed point. And the important thing here is this point is not on the line, and that point is called the focus. So what we're going to do is we're going to watch a little QuickTime movie of one of these being plotted so we can see a construction of a parabola. In this situation, what we've got is we've got our directrix, which is the line. We've got our focus, which is the point not on the line. This yellow arc represents a circle, and this red point being the center of the circle, just so we know that both of these are radii and they are equidistant. So any point on my parabola must be equally distant from the focus and the directrix. Remember, distance to a line is always measured perpendicularly. So as we continue, each of these radii are congruent. And we continue through, and we can sweep through till finally we get to a point right about somewhere in between here where we would get the vertex, although this graph does not exactly capture it because it would be perpendicular from the focus to the directrix. And we continue going, we get more and more points, and you can see that in this particular situation, any point on the parabola, the distance from that point to the focus is the same distance as from that point on the parabola measured perpendicular to the directrix. So that's the geometric definition, and what we need to pay attention to now is we need to find the focus, and we also need to find the equation for the directrix as well. And if you wish to watch that QuickTime movie a little bit later on your own, there's the address to go. Alright, also, all the formulas are listed for you on the website. With that out of the way, let's just hope that you've got them handy in the packet that I've given you. And we've got a parabola in standard form, y equals 1/2, x minus 2 quantity squared plus 1. We've done this in a previous chapter, so it should not be too difficult to remember that since 1/2 is positive, the parabola opens up. Since the absolute value of 1/2 is less than 1, that makes a wider parabola. If it was equal 1, that would be normal, and greater than 1 would be narrower than usual. Our vertex is the opposite of the number in parentheses with x, that's positive 2, and the number the same as what's outside the parentheses, 1. There's our vertex. Now, the axis of symmetry is pretty much found here in the parentheses, as we've done in a previous chapter. X equals the opposite of the number in parentheses, which is also the x value of the vertex. So x equals 2 is my equation for the axis of symmetry. What we need to find now is the focus. To calculate the focus, it's always going to be inside the bucket. So for a parabola that opens up, the x value of the vertex and focus are going to be the same, and we're going to add something to the y value of the vertex. We're going to add 1 over 4 times a. According to the formula sheet that you have in front of you, a here is 1/2, so we'll simplify the denominator first. 4 times 1/2 is 2, so that gives me 1/2, and then 1 plus 1/2 is 1.5. So the focus is located at the point 2, 1.5. If you refer to your formula sheet in the packet that I've given you, the equation of the axis of symmetry and the directrix are always perpendicular to each other. So if my axis of symmetry is x equals, my directrix is going to be y equals. And it's going to be the y value of the vertex minus this 1 over 4 times a. Now it's not 1/4 of a, it's 1 over 4 times a. So 4 times 1/2 is still 2. 1 minus 1/2 is going to give us 1/2. That's pretty much everything there is to know except for the graphing portion of it. So with the information we have, let's look at the graph, starting with the vertex at the point 2, 1. We're going to make a little chart of points to find some other ones to locate on our grid as well. So if the axis of symmetry here we said is equal to 2, we want to find some points to the left of 2 or to the right of 2. Your choice. In this case, I'm going to pick some points to the left of 2. like 1 or 0. And why am I including negative 2? Well, I noticed that an odd number for x gave me a fraction, and to avoid that, I chose an even number for my negative value. So if I put in 1, 1 minus 2 is negative 1. Negative 1 squared is positive 1. Times 1/2 is 1/2. Plus 1 is 1/2. If we put in 0, 0 minus 2 is negative 2. Negative 2 quantity squared is 4. 4 times 1/2 is 2. 2 plus 1 is 3. So we have the point 0.03. And to avoid the fractions, although this puts our point off my little graph paper here, put in negative 2 minus 2. That's going to be negative 4. Quantity squared is 16. Half of 16 is 8. Plus 1 is 9. So plotting the vertex, if we recall, was 2, 1. Here's another point on the graph, 0, 3. Here's the point on my graph, negative 2, 9. It stretches a little bit outside my graph paper. There's the point, if we want to come back for the fractions, 1, 1.5. And if we draw the axes of symmetry, we have points on the left side of my parabola, and we need their mirror images on the right side of the parabola. So if this is 1 to the left, I need 1 to the right. If this is 2 units to the left of the axis, I need a point 2 units to the right of the axis of symmetry. And if at this height, if this is 1, 2, 3, 4 units to the left, I need 4 units to the right. This lovely little purple point there is our focus, so let's review what that was. Positive 2, positive 1.5. So from the origin, positive 2, positive 1.5. There is my focus. And my directrix was the equation y equals 1/2. And that's everything there is to know about that particular parabola. The only thing that's new that we're doing that we didn't do in a previous chapter is calculate where the focus is, calculate the equation for the directrix, plot them, and be aware of the geometric definition. Now your focus should always be on the axis of symmetry inside the parabola. And we'll give you some hints. The narrower the parabola is, the closer the focus is to the vertex. The wider the parabola is, the further away it is. Now, we have done parabolas in standard form before, but look at the packet with all the formulas I've given you, and these are horizontal parabolas, not vertical. So everything's switched around. We've got x equals. So my parabola is going to open either to the left or to the right. A is still this number, and we've got y plus, and be careful, this is not h anymore, it's k, which refers to the y value of the vertex. So y plus 3 quantity squared minus 2. So as we look at our chart, since this is negative, that opens to the left. We look at our formulas in the packet. Absolute value of negative 1/4 is less than 1. It's wider than usual. And here's where students can get confused, so be very careful. The number in parentheses, we do take the opposite of it. But whatever variable it's in parentheses with, that's which part of the vertex it represents. So this 3 is in parentheses with y. The opposite of that, negative 3, is the y value of the vertex. And this negative 2 would be the x value of the vertex. So be careful not to twist those around. The equation for the axis of symmetry is still found right here inside the parentheses. Y equals the opposite of this number, negative 3. The focus is going to go left or right of the vertex since this parabola opens left or right. So that 1/4a, we're going to add that to the x value. We did that to the y value when our parabola opened up or down. But for a parabola that opens left or right, we've got to add it to the x value. So a again is negative 1/4. We're going to take 1/4 times that negative 1/4. Add that to the x value, and that'll tell us where our focus is located. 4 times negative 1/4 is negative 1. 1 divided by negative 1 is negative 1. Negative 1 plus negative 2 is negative 3, and that's where my focus is located. Directrix, now our axis of symmetry here was y equals, so my directrix is going to be x equals. It's going to equal the x value of the vertex minus 1/4 times a. We just calculated that to be negative 1 here. So we have negative 2 minus negative 1, which is the same as negative 2 plus 1, or x equals negative 1 is the equation for my directrix. And what's left is to graph these. So we're going to make a chart of points. And here's the difference when we make this chart of points. I am not going to choose values for x. We're going to choose values for y. And since y equals negative 3 is my axis of symmetry, I want to pick points above that or below that. So above negative 3 would be points like negative 2, negative 1, 0. We're going to substitute those in for y and calculate what we're going to get for x. I know it's a little different. So if we put in negative 2 plus 3 is 1, 1 squared is 1, 1 times negative a fourth is negative 1/4, minus 2 is negative 2 and 1/4. Let's put in negative 1 and see what we get. Negative 1 plus 3 is 2, 2 squared is 4, 4 times negative 1/4 is positive 1, 1 minus 2 is negative 1. If we put in 0, we'll come back to that in a second, but if we put in 1, instead of negative 1, 1 plus 3 is 4, 4 squared is 16, 16 times negative 1/4 is negative 4, minus 2 is negative 6. Alright, well let's try to plot these points. Here's my vertex. Let's scroll back so we can remember what it was. Vertex was negative 2, negative 3. So left 2 from the origin, down 3. Plot some of the points we just calculated. So there's the point negative 3, negative 1. There's the point negative 6, positive 1. And I'm not plotting the fractions here, which we don't need since we have a couple of good points that aren't fractions. Here's my axis of symmetry, y equals negative 3, horizontal line. So my parabola is opening to the left, and I need the other half of it, the mirror image, across the axis of symmetry. So if I have a point here that's 2 units above my axis of symmetry, its image is 2 units below. And this is 1, 2, 3, 4 above. I need a mirror image 4 below the axis of symmetry. Graph that parabola, and let's plot the focus. Let's scroll back to remember what it was. The focus was negative 3, negative 3. So we start at the origin, go left 3, go down 3, put a dot there. There's our focus. Our directrix, let's go back and remind ourselves what that was. X equals negative 1. So x equals is a vertical line, and that crosses at the x-axis at negative 1. So here's my axis of symmetry in red, parabola in blue, focus in this magenta colored dot, and directrix in the magenta colored line. Alright, the other thing we need to know about all the conic sections, including parabolas, are eccentricity. And in this case, the eccentricity of a parabola is 1. The distance from the focus to any point on the parabola is the same distance as that point to the directrix. So as we saw this construction, virtual construction, at the beginning of our virtual lecture, any point you pick, the distance from that point to the focus is equidistant from that point to the directrix. And what we have then is the distance from the focus to the point is the same, and anything divided by itself is 1. So the eccentricity of a parabola is 1. And we'll show this table when we cover every conic section. Remember, circle, eccentricity was 0. Parabola, eccentricity is going to be 1. And we'll look at ellipse and hyperbola at a later date.